So now let us see an example for 0, 1 knapsack. Okay. So the example is very straightforward. Okay. So before we go into the example, I actually wrote the recursive equation for the value of a knapsack with n items and with the capacity of the knapsack equals to W. Okay. So this will be equal to the value of the knapsack with n-1 items and W if the weight of the nth item is greater than the capacity of the bag. Here we are obviously skipping the nth item from the bag, right? So this is one case. The second case is that we'll take the max of the two possibilities again. In the first possibility, we are not considering the nth item in the bag. Okay, so it will be the max of k into n-1 comma W, right? So in this case, we are not considering the nth item to be present in the knapsack. That's one possibility. Or let's consider the nth item in the knapsack, which means its value will be added here. And the number of items that I have now is n-1 items. And the total bag capacity I have right now is W minus WTN. This is the weight of the nth item, right? So I hope this is clear, as we have already discussed this recurrence relation. Okay. So this is the otherwise case. If weight of n is less than equal to W. Okay. I just wrote it that as OW, which means otherwise. Let's keep this recurrence relation here handy. Now, in our example, let's say I have the capacity of the knapsack, which is W, as 7. Okay. So this is what we are starting off with. Now, let's assume I have 4 items. This 0th item is something that I just introduced for simplicity. Okay. So just ignore the 0th item. I have 4 items right now. Item 1, 2, 3, and 4. So this is my n. Okay. So this represents my n. Here my n equals to 0, 1, 2, 3, and 4. Okay. So now the weight of the first item is 1 and the value of the first item is 1. The weight of the second item is 3 and the value of the item is 4. Weight of the third item and its value, weight of the fourth item and value. Okay. So if you want, I'll just write n equals to 0, n equals to 1, n equals to 2, n equals to 3, and n equals to 4. So this is the data. This is what is already given to us as input. Right? This is what is given to us as input. Now, if you notice, my W can be, so see, for various values of W, I'll start doing it. As we have seen in the pseudocode, we'll start with W equals to 0, 1, 2, 3, 4, 5, 6, up to 7. Right? Now, let's start filling it. Obviously, if I have only 0 items, whatever is the capacity of the bag, right, the value will also be 0. Right? So, in this matrix or in this table, we are going to fill the value of the bag. We are going to fill the value of the knapsack or the bag, right? Which is nothing but our k values, k, n, comma, W. Okay, because as I said, k, n, comma, W is basically the value of the knapsack when I have n items and the capacity of my bag itself is W. Okay, so it represents the value of the knapsack. Okay, now let's look at this part. Okay, let's start here, right? If my weight equals to 0, okay, if my weight equals to 0, what happens? Here, the weight of this item, look at this, the weight of this item and the weight of this item, the weight of this item and the weight of this item, all of them are greater than the capacity of my bag, right? So in this case, what happens? It goes into this condition, right? So k of, see, look at this, what do I have here? If you want to write this down, what do I have here? I have k of n equals to 1, comma 0. K equals to 1, comma 0 is what I want to compute, right? It will be equal to k equals to n-1, comma W, right? What is n-1? Here, this row, 0, 0, comma W, for the same W, right? And why are we choosing this? Because the weight of this item, is greater than the capacity of my bag. So it satisfies this condition. Hence, what do we do here? K1, comma 0 is equal to K0, comma 0. So 0, comma 0, which is equal to 0, right? So this will be 0. Okay, look at this. The way I am filling this table, similarly, you will get 0, 0, 0 here. The way I am filling this table is basically applying this recurrence relation step by step. Now, what do I have here? Okay, so let me just erase this. Okay, so what do I have here? I have K, n equals to 1 and W equals to 1. Okay, K11. Okay, now the first thing, is the weight of the first item, is the weight of the nth item or the first item here, is it greater than the capacity? No, it is just exactly same as the capacity. So we do not have this first case, we go to the second case, right? So K11 will be, okay, so let me actually write this. Let me just erase this so that I can use this as temporary space. Okay, so K11, so what will K11 be? K11 will be max of, right, K 0, 1, okay, look at this, K 0, 1, comma, K 0, W minus weight. What is W? W equals to 1. What is the weight of this? 1. So 0, 0 plus value of 1. Right? So what is value of 1? Value of 1 is 1. So value of 1 is 1. Okay, what is K01? K01 is 0. Okay, so it's a max of, so which is equal to the max of 0, K00. K00 is 0. Okay, so it's a max of 0, 0 plus 1, which means it will be equal to 1. So we fill this value as 1. Right? So we just fill this value as 1. See, what am I doing here? I'm simply applying the recurrence relation. That's all. Right? So now, if you look at this, what will this be? This will be K12. This will be K12. Now, the weight of this item, the weight of the nth item is less than equal to the capacity of the bag. So we go to the second condition. In the second condition, what do we have? K12 equals to K02, max of K02 and K. So this is n minus, okay, so this is K. Okay, let's actually write it down, right? Let's actually write it down. Let's actually apply this, K n minus 1. So what is my n now? This is my n and this is my W, right? K n minus 1, 0 and 2. Okay, this is one possibility, comma, K n minus 1 is 0, W minus the weight of the nth item. What is W? W is 2. And what is the weight of the nth item? 1. 2 minus 1 is 1 plus the value of this item. What is the value of this item? Value of the nth item is 1 itself. Okay. What is K02? K02 is 0. Right? K01. K01 is 0. 0 plus 1. So max of these two is again 1. Right? What am I simply doing? So if I keep applying this recurrence relation, I can fill this like this. Right? So again, I'm just filling in the values here. I'll show you some interesting values which are not trivial. Okay. So let's take this value. Okay. So I'm just filling this in. Of course, if you keep applying this recurrence relation, you can fill this in also. Now here comes the fun part. Okay. What is this? This is K of n equals to 2 and W equals to 3. Right? K23. What should K23 be? Now if you notice, what is the weight of this item? The weight of this item is 3. Right? What is the capacity of the bag? 3. So now WTN, right? This is your WTN, right? WTN is 3. 3 is less than equal to the capacity of the bag. Right? So this first condition will not be executed. It is a max condition that we'll go into. So let's go into the max case. Max of K n minus 1 is 1 and weight is 3. K13 or K of n minus 1, which is 1, and subtract the weight of the, subtract WTN from W. What is W now? W equals to 3. What is WTN? 3. If I subtract it, becomes 0 plus value of this item, value of n, right? N equals to 2, value of n equals to 4, right? This is what we have. So which is equal to max of, what is 1, 3? 1 and 3, right? N equals to 1, W equals to 3. This is 1. What about 1, 0? 1 and weight equals to 0, which is equal to 0, right? N equals to 1, weight equals to 0. So this is equal to 0 plus the value of the nth item. What is n now? Remember, this is your n and this is your W, right? What is value of n? It is nothing but value of 2, which is equal to 4. Now, what is the max between both of them? 4. So you basically fill 4 here, right? You basically fill 4 here. Okay. So I'm basically applying this recurrence relation step by step and filling this whole matrix. Okay. So if I continue filling this, So this will become 5. Okay, I'm not going step by step, but you can easily fill this. It's not rocket science. Okay, just in the interest of time, I'm going ahead. Now let me show you another example, just so that you get some clarity. Okay, let's actually see this. Let's actually see this. Okay, so what is this? Okay, let's see that example. Okay, just so that you understand how I'm filling each of these cells. I just wanted to show you a few examples. What is this? N equals to 3 and weight equals to 7. So what do you have? You have K, N equals to 3, weight equals to 7. Okay, this is what I want to fill. What is it equal to? Now if you notice, the capacity of my bag is 7. And what is weight N? What is weight N? Weight N is 4. So 4 is less than equal to 7. So we will not go into the first case. We will go into the second case. In the second case, what do I have? I have max of K N minus 1 comma W. What is N minus 1? K N minus 1. N minus 1 is 2 and W comma K N minus 1 comma N minus 1 is 2. Right? N minus 1 is 2. W minus weight of the nth item. What is W is 7. What is the weight of the nth item? The weight of the nth item is 4. So if I subtract 7, if I perform 7 minus 4, or if I subtract 4 from 7, I get 3 plus value of this item. Right? What is the value of this item? 5. Okay, so let's see this. What is max of 2 comma 7? Right? That's what we want, right? So this is max of 2 comma 7. N equals to 2 and 7. This is 5. And 2 comma 3. N equals to 2 and weight equals to 3, which is 4. 4 plus, what is value of not 5, sorry. This is value of N equals to 3, right? Sorry, value of 3, not 5. This is value of N, right? Value of 3. What is value of 3? 5. What is the max of both of them? 9. So you fill 9 here. Okay, that's how you fill the whole thing. You're simply applying this recurrence relation over and over again and filling the whole matrix. Okay, so one thing that you learn from this now, one thing that you'll quickly learn from this is that, okay, let me just erase this temporary space. One thing you'll notice is the maximum value you can get for this knapsack is 9. Right? So that's what we got, right? So what are we filling in this, each of these cells? We are filling in K and W, right? And when N equals to 4 and W equals to 7, we got a value of 9, right? Very simple. Now here comes the fun part. Okay, now here comes the fun part, which is we know the total value, but which of these items are present in the knapsack? How do we determine this? Now first, let's work backwards from here. How did I get this 9? What is this? This is K, N equals to 4 and W equals to 7. Right? I got this value as 9. How did I get this value as 9? Okay. So this was, if you look at this item, its weight was 5, which is less than W. So it didn't go through the first case. It must have gone through the second case. So I got this value as max of, let's actually fill that in, right? K, N minus 1. N minus 1 is 3 comma 7. Or K, N minus 1 is 3 and weight minus this weight of this item. What is, so this weight, the capacity is 7. 7 minus 5 is 2, right? 7 minus 5 is 2 plus the value of this item, which is 7, right? I got from these two. What is K37? K37 was 9. So max of 9 comma K32. K32 is 1. Right, K32 comma 1 plus 7, right? So max of these two is this. So which means where did this come from? This came from K37. This came from K37, right? When it came from K37, what is this option? This option basically, look at these two options. In this option, I did not include the nth item. In this option, I included the nth item. Okay, because this is the option that generated this 9, which means item 4 will not be there. Item 4 will not be there in my knapsack because I got the optimal value by not picking the nth item to be part of my knapsack. Okay, I hope this is clear. Okay, now the next question is, how did I get this 9? The next question is, how did I get this 9? If you recall, we actually worked out how we got this 9, right? We actually worked it out, but let's do it. We have k 3 comma 7. How do we get this 9? Right? Because look at the weight here. The weight here is 4. 4 is certainly less than 7. So we didn't go through the first option, we went through the second option. So this was max of k 2 comma 7, but k 2 comma 7 is 5. K 2 comma 7 is 5. It didn't come from this. So it came from the second option. What was the second option? K n minus 1 comma the weight of the nth item, w minus weight of the nth item. What is w? W is 7. Right? What is the weight of this item? 4. Right? So it came from k23 plus the value of this item. Right? Which was 5. And when I choose this option, what does it mean? It means I'm selecting the nth item, which means I'm selecting this item. Okay, that's how this value was generated. This value was generated by actually selecting this item. Okay, so what is K23? Now let's go to K23. K2 and 3. So this was the next item. Okay, so I did 4 plus this 5, which got me 9. Look at this. This 4 plus this 5 got me 9. Okay, that's how I got this 9. Not from here, because this was only 5. This is 4 plus 5. Okay, this was generated by adding item 3 into my knapsack, and the total value increased from 4 to 9. So from here, I directly jump here. Okay, and I tick this item saying that this item is present in my knapsack. Okay, very good. So now I've reached here. Now, how did this 4 get generated? Okay, if you notice, how did this 4 get generated? We worked that also out. Okay, this 4 got generated because the value of this item was 4. Okay, let's actually write it down just so that you are clear. Okay, it's better to write it down so that it's much more clear. So what is this? This is k n equals to 2, right? And w equals to 4. What was k24? What is a possibility? Look at this weight. Look at this weight, 3. 3 is less than or equal to 3. So we did not go through the first case, we went through the second case. What is the second case? It is the max of, right, kn minus 1, which means k1 comma 4. But this is 1 comma 3, right, not 4. This is 1 comma 3, not 4. Okay, k2 3, right, the value is 4. It's k1 comma 3, but k1 comma 3 is only 1. So it didn't come from this. Right? Where did it come from? It came from k n minus 1 comma. So n minus 1, this is n equals to 2, so n minus 1 is 1. The weight of the value of, so the weight here, which is 3 minus 3, it came from that, 0. Look at this, weight of the capacity of the knapsack minus the weight of this nth item, right? So this becomes 0 plus value of this nth item. So k10 is 0. So 0 plus, 0 plus, this is 2, value of 2, which is equal to 4. So this got generated, see, this literally got generated from 1 comma 0. This got generated from here. This got generated from here. And I'm taking the second option, which means n equals to 2 is also present in my knapsack. Now, since I reached here, there is nothing else to do. Like, see, look at this. Once I reach this place or this place, there is nothing else to do. Because here the capacity of my knapsack is now 0. Here the number of items in my knapsack are 0. So the total at the end of it, there are 2 items in my knapsack, which is item 2 and item 3. And if I sum up their values, I get 9. Okay. So this is how you solve knapsack, you solve the 0-1 knapsack example by simply using this recursive equation. See, what did we do in this whole exercise? We simply kept using this and used the logical interpretation of this recurrence relation. That's all we have done. It's a very simple exercise. Of course, it's a manual exercise. You got to be careful. It's a manual exercise, drawing this table, everything. But it's an exercise worth doing because you will have a better appreciation of how everything is implemented using dynamic programming. And look at this. The very fact that I'm drawing this table, shows that I'm using dynamic programming. And I'm also using a bottom-up type of dynamic programming because we started filling from these values towards the larger value, right? We started filling for n equals to 0, w equals to 0, n equals to 0, w equals to 0. So we started filling these values first, and then we kept increasing, right? We kept building up to get n equals to 4 and W equals to 7.